GATE 2016 Set 1 EC question number 55. It says the far zone power density radiated by helical antenna is approximated as W dad equal to W average equal to C naught 1 by R square cos to the power 4 theta AR cap. Radiated power density is symmetrical with respect to phi and exists only in the upper hemisphere. So theta is 0 to pi by 2 and phi is 0 to 2 pi and C naught is a constant. Power radiated by the antenna in watts and the maximum directivity on the antenna are given and asked to be determined. So in order to solve this problem, you need to know that power radiated can be determined from the average power density by, if this is average power density and this is elemental surface, so do surface integral and you get the power radiated. Also directivity D naught can be defined as 4 pi meant to maximum radiation intensity divided by power radiated. If this is power radiated, P rad, I can say radiation intensity can be defined as power density per unit solid angle. That can be written as, so this is 1 by R square and this is R square multiplied by power density. Power density is W dad. This is power density. Elemental area, elemental surface, that is for a spherical system, can be written as R square sine theta d theta d phi in the radially outward direction. So now coming to the solution, W radiated in dot ds surface integral is the radiated power. So what is it coming? 1 by R square cos to the power 4 theta into C naught into R square sine theta d phi. Now these limits are theta and phi. For theta, and this is phi, pi by 2 to 0 to pi by 2, phi between 0 to 2 pi. Now what is it coming? R square getting cancelled and you have in double integral theta to 0 to 2 pi and phi 0 to, theta 0 to pi by 2 and phi from 0 to 2 pi sine theta cos to the power 4 theta d theta into d phi. So this is theta. This can integration for theta can be done, and aside d phi integration is independent, so can be taken outside. So it is 2 pi because this is phi and 2 pi minus 0. So multiplied by, if you solve this integration, 0 to pi by 2 sine theta cos to the power 4 theta d theta, this integration you need to solve. So cos theta, it is u, then minus sine theta d theta equal to plus du. So just replace sine theta d theta, this term. So this is cos theta is u, so u to the power 4 and sine theta d theta is minus du. And if cos theta is u, then for theta equal to 0, u equal to 1, and for theta equal to pi by 2 is 0. So 1 to 0 you need to integrate at the improved limits. So this is by substitution we get. By substitution, outside you have c0 into 2 pi, that is there. So I can write it as c0 into 2 pi multiplied by this minus sign, right? So I can flip them. integration 1 to 0, 0 to 1 now I can write, and this is plus u to the power 4 du. So c0 2 pi multiplied by u to the power 5 by 5 1 to 0, right? Because 1 to 0 and u to the power 5 by 5, because integration of u to the power 4 du equal to u to the power n plus 1, which is 4 plus 1 is 5 by 4 plus 1 is 5. Now this is 1 by 5 multiplied by c0 multiplied by 2 pi. So this value is coming out to be 1.256 c0. Trying to determine the directivity, right? As per formula, directivity equal to 4 pi multiplied radiation intensity. I know it is r square into w dad. It is u max, which is nothing but c0 into cos to the power 4 theta. Let's multiply r square with w dad. So c0 cos to power 4 theta is the radiation intensity. Now this is radiation intensity divided by power radiated. This can maximum is plus 1, so don't take cos, just take 4 pi c. So c0 gets cancelled, and 4 pi by 1.256 nearby 10.005. So d in dV is 10 log base 10, 10.005, which is approximately 10. Okay, so the answer is 10 dB and 1.256 C0. So B is the correct option.